David Smith here with another Flipped Classroom math video. Today's topic, hexagoning the circle. This is one of the key exercises in the Orchard Hideout unit. Techniques you develop here will help you complete coming assignments, such as tonight's assignment, which is octagoning the circle. Same process, slightly different numbers. If you master this, you'll be good. Okay, let's get started. The idea is that we have a circle over here that has a radius of 10, and it's inscribed inside a regular hexagon. Another way to say that is the hexagon is circumscribed around the circle. Both things mean the same. What you're given in this problem is that the radius of the circle is 10, and what you're asked to find is the area and the perimeter of the hexagon. Fortunately, this is possible, just a bunch of steps and quite a bit of critical thinking. At first, you might be looking at this going, whoa, how do I do that? All I know is the radius of the circle. Well, remember, you do know some other things, and it's a geometry problem, so don't be afraid to start drawing on your picture and seeing what you could come up with. In this case, there's some cool stuff here. What I can do is I can make draw another radius out here to the corner of the hexagon. And if I realize that that has to be a right angle there, I'm well on my way. Now, I could use some trigonometry here if I know a couple things, or just one thing. If I could find some angle measures. I know that's 90. I would love to know that angle. Here's something to see. All those central angles of the hexagon are 60 degrees because there's 6 of them in 360 degrees. It's a regular hexagon, so that means that each of these sections, like that one too, are going to be 60 degrees, okay? It's just 360 divided by 6. Now, this one here is going to be 30 because it's half of the 60 degrees that comes from there. So now I have this triangle. I'm going to blow it up. Here's my 10, which is the radius of the circle. It's also the side of this right triangle. Now I know this angle here is 30 degrees. Now I'm well on my way to solving this problem. I can use trigonometry to find this side, tangent function, which is also this length here of the entire hexagon. If I know this x, then I can just multiply it by 12 to get all the way around the hexagon. How do I know 12? Well, I know that this is half of this whole side. There's 6 of these whole sides in the hexagon, so I have 12 x's would get me all the way around and give me the perimeter. So let's do some calculating. Perimeter. I need to find my x. So I mentioned before that it's the tangent function. Remember your SOHCAHTOA. Tangent is TOA, which is tangent of theta equals the opposite over the adjacent, ADJ. Tangent, opposite over adjacent. So know your SOHCAHTOA. If this is new to you, then you need to review that to understand this step in solving this problem. So now what I can do is I can do tan 30 is adjacent, opposite over adjacent. So tan 30 equals x over 10. Now I can rearrange this equation to get x alone, multiply both sides by 10, and I'm going to have 10 times tangent of 30 equals x. Okay? Now before I start punching in some buttons on my calculator, let's take this one more step. Remember before we talked about how many of these x's are in the perimeter? There's 12 of them, so the perimeter, I'm going to abbreviate that, perim, is going to be 12 times 10 times the tangent of 30. Now it's time to pull out your calculator. I always like to do my calculations, do all my manipulation first, get my equation exactly where I need it, then grab the calculator and start punching buttons. So if you do 12 times 10 times a tangent of 30, what you're going to get is something like 69.3. So that's the perimeter of our hexagon. Okay? kind of a lot of steps here. If I went too fast for you, just stop, rewind, watch that again, pause it along the way, do some thinking. Okay, so let's take a look at the area problem. This one, actually, now that we've done perimeter, we can use what we've done here to solve for area. So I'm going to bring your attention back over to our little triangle here. How many of these triangles are in the hexagon? Think about that. If you came up with 12, you're right. Because there's 1, 2, that gets this slice, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of those. So if I can figure out the area of this triangle, all I got to do is multiply it by 12 and I'll have the area of the hexagon. So I'm going to write this here. Area triangle, I abbreviated area triangle. Now, remember your triangle area formula? 1/2 base times height. 1/2 base times height. Now if you look at that triangle, you'll see that we know some things. We know what x is. Remember, we figured that out from here. So it's 1/2 times 10, because here's our base, times tan 30, times our height, which is also 10. Okay? So now I know the area of my little triangle is 1/2 times 10 times tangent 30 times 10. Now how many of those little triangles do I have in my entire hexagon? It's 12 again. So now the area of the hexagon is going to be 1/2 times 10 times tan 30 times 10 times 12. So if you do all of this multiplication, you're going to wind up with 346.4. So that gets you the area of the hexagon. Let's review, okay, just to make sure that that makes sense. The problem is to find the perimeter of this hexagon. We used the radius of the inscribed circle to set up this little triangle, and then we used the tangent function up here to figure out this value in this little triangle that's part of that. And once we found the x, we just multiplied it by 12 to go all the way around the hexagon to get our perimeter of our hexagon, 69.3. We followed a similar process to find the area of the hexagon. Again, we jumped down into this little triangle and we figured out the area formula for that, 1/2 base times height. So we grabbed our information that we calculated, 1/2 times our base, which was x, which we found out here was 10 times the tangent of 30. So 1/2 times 10 times the tangent of 30 times the height, which is again also 10. Then we realized, before we even calculated, we realized that the area of the hexagon is just 12 times the area of the triangle. So I followed this again. I did 10, or 1/2 times 10 times tan 30 times 10. That's the area of the little triangle. Then times 12, because we have 12 of them. So that gave us our 346.4. Action. Okay, the second part of this exercise involves coming up with a general formula for a hexagon circumscribed about a circle with radius r. Not radius 10, but anything. This formula would allow you to do the calculations for any diagram that's drawn in this way. So let's do this. All we're going to do is the same exact steps, but instead of using 10, we're just going to keep r there. Okay? So I have my diagrams from before. I crossed off my 10 and I wrote r. So remember, we were finding x first, one little piece of the perimeter. So x was equal to 10 times tan 30, right? However, like I said, no 10s anymore. We have just r. R times tan 30. So this would be a way to find the little x for any size diagram, whatever the radius is. What did we do to that? We multiplied it by 12 because there's 12 of these x's going all the way around. So now we're going to have 12 times r times tan 30. Okay? So that would be our formula. I could actually take away the 12 and write the perimeter of the hexagon. Now, I can simplify this down quite a bit. Tan 30 is just a decimal, which we then can multiply by 12, and what that ends up giving us is 6.93R. Okay? So that's our formula. If you have a hexagon circumscribed around a circle of radius r, and you want to know the perimeter of the hexagon, you just multiply the radius times 6.93. Okay? Let's do the same thing for area. So we're going to do the same bit. Now we need to use the area formula and remember our r. Okay? So area is 1/2 base times height. So it's 1/2 x. Now, x we know is right here. So it's 1/2 times r times tan 30. So this is the area of one of these. If we want the area of the hexagon, or area hex, that's going to be 12 of those. So we're going to get 12 times 1/2 times r times tan 30 times r. So if we can crunch all the numbers, remember we can multiply 12 times 1/2 times tan 30. These are all just constant numbers. Put those in the calculator, and then we know that r times r is just r squared. So what you get from this is 3.46r squared. Okay. So there's a couple things to notice. Perimeter is a distance, just r. Area is a squared quantity, and guess what? We did get a squared in there. So that's a confirmation that we're on the right path. You could test any of these formulas by plugging in 10 for r and seeing what you got. I think you can probably see that that would work already. Just plugging in 10 for r here moves the decimal 1 over, 69.3. That's what we got for perimeter. Plugging in 10 for r here moves the decimal over 2 places, gives us 346 for area, which is indeed what we got in the last calculation. I really hope this video helped. I know I went quick, so if you're still a little shaky, go back and watch it slowly, pause it, see if you can dig into it. Take good notes. When you come back to class, ask me questions. That's totally fine with me. If you enjoyed the video, give me a like down below. You can also subscribe.